Lesson 1-2, Properties of Real Numbers. Classify real numbers and use the properties of real numbers to evaluate expressions. Let's take a look at this statement. All real numbers are either rational or irrational. All real numbers are all the numbers that we can put on the number line. So all of these numbers are on the number line. The first category is rational numbers. And we first learned rational numbers when we were learning how to count as a youngster. And then when you include 0, you're talking about whole numbers. 0, 1, 2, 3, 4, 5. When we include the negative counterparts, then we include integers. These are integers. And anything that can be written as a fraction, which integers can be written as a fraction, whole numbers, and natural numbers, those are what we call rational expressions. Now, rational written as a fraction. Now notice this -8 halves is rational, but it could also be called an integer because it's also -4. Now this with repeating, anytime you have repeating decimals, that always comes from a fraction, like 1/3 is 0.333 repeating. Irrational numbers are numbers that cannot be written as a fraction, like pi, √2, √3. Okay, take a look at this screen, and you might want to pause it so that you can take a look at it a little bit longer. It's another way to show the relationship. Here are all real numbers, all the numbers on the number line. There's two categories, rational, which is Q, and irrational, which is I. And again, there's subsets of rationals that we can talk about: natural, whole, and integers. All right, let's go ahead and start doing some problems. -23, what kind of number is that? Well, -23 is right here in this category, which is a, let me go ahead and put this, integers right here. So this is an integer, and once it's an integer, it's also part of rationals. And when it's part of rationals, it's also part of reals. That's why there's 3 answers here. Now, -√50 is going to be an irrational number, so it's going to be in this category right here. And once it's in irrationals right here, then it's also in reals. So that's why there's the 2. Now we have -4/9. -4/9 is a rational expression, which is right here. Rational expression is right here, and it also is part of the reals. Okay, so let's go ahead and do some problems here. -185. -185 is an integer. It's in this category. So we know it's going to be an integer. We also know that it's going to be a rational expression. And we also know it's going to be part of the reals. Now this will simplify to -7. And -7 is also part of the integers. So this will be z. And then it's part of the rationals, Q, and it's reals. Now this is not an irrational number. The square root of 49 can be simplified, so we can't put it in the irrational part. Okay, √95 is going to be, let me choose another color, is an irrational number. So it's going to be in this category, which is I. And once it's in I, remember it's also part of the reals. So every one of these answers will have a real part. -7/8 is going to be right here. Let me choose another color. It's going to be in rationals. So that's Q. And when it's in rationals, it's part of the big group, which is R. Every single one of these is in the real number category. Your turn. Pause. And here's the answer. Your turn. Pause. And here's the answer. Your turn. Pause. And here's the answer. Now let's take a look at properties of real numbers. You might want to pause this to take a look of all these properties. Commutative is about the idea of switching order. Associative is about the idea of grouping the first 2 or the last 2, and your answer will be the same in addition or in multiplication. This does not work for subtraction or division. Identity for addition is 0. In other words, 0 doesn't affect the addition. The identity for multiplication is 1, because when you multiply by 1, it doesn't change the answer. An inverse is the number that you're going to get the identity. So A plus the opposite of A are inverses of each other, because then you get the identity 0. Inverses in multiplication are a and the reciprocal 1 over a. That's how you're going to get the identity. Closure means when you add two real numbers, you get a real number, or when you multiply two real numbers, you get a real number. And the distributive property, where multiplication is over addition, and then you can go in reverse. Okay, let's take a look at this property right here, and we want to identify it, and you can see that the order hasn't changed, so it's not commutative, and you can see there's some association with a parenthesis, so we're associating the last two in the multiplication and the first two in multiplication, so that's called the associative property of multiplication. Now they're asking us to name the property here. Now I can see some associating going on, but I don't see it on the other side, so it's not the associative property. I do see a multiplication over addition, and that reminds me of multiplying like this, and that's going to be the distributive property. All right, your turn. Pause. And here are the answers. Now let's take a look at simplifying expression. That's why we learn these properties, so that we can take a look at some expressions and simplify it. So in this one, you can see we're using the distributive property, and then we're using multiplication property. And then to get the q's by itself, we're switching order. That's a commutative property. And then we're using the distributive property to combine these like terms, and then we simplify here. So we really don't have to go through every single one of these steps, but I just want you to understand that's what we're doing when we're going through this process. So I want to distribute, and that answer will be 12x minus 6y. Now don't forget to distribute a -2, so that'll be -6x, and distribute a -2 to a positive, that'll be minus 2y. Now I'm not going to use the commutative property, I'm just going to understand to add like terms like this. And so that answer will be 6x minus 8y. Your turn. Pause. And here's the answer. Pause to see if you can find the error. And here's the answer.